Oh, hi everybody. So today we're gonna walk through the legal question 314, binary tree vertical order traversal. Given the root of a binary tree, return the vertical order traversal of its node values from top to bottom, column by column. If two nodes are in the same row and column, the order should be from left to right. Okay, so what does it mean by vertical order traversal? We can take a look into the first example. So we have a binary tree and we are gonna traverse the tree and then output the result um column by column. So the first column is like a single nine, and the second column is a list of 3 and 15. And then for the third and fourth one, similarly, just a list containing only one node. Um, I mean node values, so integer specifically. And so there's like an edge case in the second example. In the middle column, 0 and 1 are like they have the same axis value. So uh I mean like x coordinate value. So um but we still need to order them within that column list. So now we will follow the order of left to right. So the middle column list will look like 3, 0, and 1. Okay. The third example is very similar to the second one. So for this problem, obviously, we need to traverse the tree in a regular way. So you can do BFS or DFS, both work. And personally, I prefer to use BFS here. So we're gonna use a queue. And we're gonna store the root node into the queue first. And aside from the node, we also need to record the x and y value of each node. So, for example, the root node always has an x value of 0 and a y value of 0. And once we go to its left child, for example, 9 in this case, the x value will be decremented by 1 and turns to be -1 here, but the y value will be incremented by 1, so turns to be 1 here. I know it's like a little bit like it's against the intuition somehow, but the reason why we need to increment the y value while going bottom is because later on when we try to output like the vertical traversal, we will order everything we stored and from like in ascending order. So for x-axis is like relatively easier to understand. From left to right, the x value goes like from smaller to larger. But for the y value, similarly, when you go from up to bottom, the y value should like grow as well. So yeah, when you go to the children of of current node, um, the y value should be incremented instead. Okay, so um, and then we can after this process of BFS, getting all the node values and their coordinates, uh, we can get like a list containing multiple tuples. So each tuple contains the node, the x, y value, and the y value. And then we need to order the list. Um, First of all, um, by the order of x, and second, by the order of y. And after sorting the list, we're gonna um, store those tuples into a list of list. So for example, in Python, we're gonna use a default dict list of list. So the key of the default dict would be the x value, And the value of the default dict would be a list of all the node values like in that column. So for example, we're gonna have something looks like um uh okay, so let's take the first example. Um we're gonna have -1 with a list containing 9, and then x value of 0 mapped to a list containing 3 and 15, and then key of 1 mapped to a list of 20, and then similarly for the rest. So we're gonna have a map looks like this. And then we're gonna like return all the value list only and store all of them into another bigger list, just like the example output. Okay, so let's get started coding. Um Before everything starts, we need to consider like a higher level edge case. That is, what if the tree is null? So if not root, we're gonna return an empty list. This edge case is not discussed in the examples in the question, but we'll just assume we're gonna like output nothing for like an invalid parameter. Okay. And then uh let's just create a map. So the map will finally look like this. So let's just call it map list. Okay. Oh, sorry, no. Let's create a list of tuple first. So in the list of tuples, there will be a lot of things like um 0, 0, root, and -1, 1, and root's left child, stuff like that. Yeah. So let's call it tuples. Okay, great. And then we can start to use BFS to traverse the whole tree. So the first step of BFS would be create a queue and initialize it with root. So we'll just call it Q, and then we're gonna use the DQ library, like functions and built in Python. So yeah. So we're gonna record not only the node, but also the X and Y value of it. For root, it will be both 0. And also before we move on to the next step, we need to import the libraries we need. So I've already done it before we start. So let's just continue. Okay. And then we're gonna iterate the queue continuously. So while queue is not empty, we're gonna first pop the first element. Always pop out the first element. And it would be node X and Y. Okay. And then after we pop them out, we need to store them back into the tuples we create, but in the format of like tuples, right? So we're gonna add them back to tuples. Um, but sorry, but in the format of X first, and then Y, and then no value. Yeah, no value. Why is like that? Because it is quite important that we store the X first and Y second. It will play a role when we try to order the tuples list. Okay. And then we will just move on to the left and right child of current node. Before that, every time when we move on, we need to ensure that we check the node we're trying to visit is not null. So if node left is not null, we'll add the node and also the coordinates of the node into the list, tuple list. So, oh, sorry, not tuple list, into the queue for the next round of iteration. Okay, so queue, um, append, and we're gonna store the node left child, and then x minus 1, but y plus 1. And we'll do the same thing for right child. Okay, cool. So then we'll jump out of the loop when the queue is finally empty. That means we've already visited every single node in the tree. And then we're gonna sort the tuple list. First of all, x, the value of x, and then the value of y. Because when we try to output um the the nodes with smaller x value always go first. And within that list, containing all the nodes having the same value of x, will then order them with the value of y, right? Okay. So we're gonna just sort it. Tuples sort with the built-in sort function of Python. And remember, the time complexity here will be n log n. Okay, and then so we have a tuple list right now like this, but ordered already. And then we want to convert this tuple list into a map thing look like this, with the key of x value and value of list containing all the nodes in that column. So we're gonna create a new default dict. I'm gonna just call it result. Dict of list. Okay. And then we're gonna store those tuple elements into the result dict. So for x, y, node value in tuples, we're gonna append them into the map. So result, the key is the x value, and the value is a list. So we're gonna append the node vol one by one. And for now, we'll just get rid of y because it only matters when we order the tuple list. And later on, everything will follow the order. Okay. So now, up until now, we have the list. Oh, sorry, not the list. We have the map that we're looking for, like this. But what we really want to output is a two-dimensional list containing all the value list only. So we'll just get rid of all the x value. So we're gonna output 9, 3, 15, stuff like that, right? So we're gonna return a list containing the value list in that map. So result x for x in okay, So, okay. Yeah. So, okay, cool. Um, um, I don't really think we need to sort the result list one more time, but let's see. What if we just get rid of the sorted? Okay. Yeah, we'll traverse every single key value pair in the result default dict and then append all like add all the value lists into the new list. Okay, let's just try running the program. Oh, okay. Oh, it looks like we still need to sort the result list before we return it. Okay, cool. Let's just try to run it one more time. Oh, it's not working. Um, okay, the problem is we messed up the value. Okay. The in this third example, 10 should come first because it goes to the left side compared with 9. Okay. So that means we have something. Oh, okay. Um, that is because 10 is on the right and 9 is on the 10 is on the left and 9 is on the right. And then we still need to like follow the order from left to right, no matter what. Okay. Um, I think we can do um okay. Let me just take a minute to look into the code and see what happened. And so that's why. Okay, so I think probably because we didn't sort the tuple list correctly. And in order to fix this error, we will try to like go deeper into the details of tuples and then sort it without using the sort function directly. So, okay. Um, yeah, so similarly, we will just use um sort by. Oh, I just realized. Okay, so if we use the sort function building Python, it will just sort the first value, I believe, right? The value of x. Oh, wait, not only. Okay, whatever. So let's just go deeper into the list and let's use the lambda thing for like a more detailed version of sorting. So okay. Uh we'll sort of uh lambda I wait, um let's call it pair. Oh wait, let's just call it X. Okay. And then we'll try to order them with the X value first. So index 0. and then the y value second. So index one. We don't do we really care about we don't. Okay, so let's see if it works right now. Nope, sorry. Oh, positional argument for keyword. Oh, okay. So I think I had some syntax error. We need to use a parenthesis here. Okay, let's just try one more time. Okay, it worked right now. So, if we use the sort algorithm, sort function directly, um, it may sort the first value, like the x only, right? Yeah. Okay. Wait, I don't really know actually. Okay. Yeah, whatever. I think we fixed this problem. And the time complexity of the problem would be oh like n log n still because we use the sort function. And the space complexity of it would be O n because we use a queue. Yeah, so I'll just write it down here. Time is O n log n. And space would be O n. Okay. And log n because we use sort function. And O n because we use a queue. And not only queue, we use a default dict list, whatever, like yeah, several extra data structures that occupies space of n. So the big O will be just n. Okay, cool. So great. Let me just submit it and see if there are any extra arrows. Okay, it worked. Thank you.